Hi everyone, let's solve this problem. Find median from data stream. The median is the middle value in an ordered integer list. If the size of the list is even, there is no middle value and the median is the mean of two middle values. For example, if the array is 2, 3, 4, there are like odd number of values in the array, then the median is the middle value. But if the array length is even, then we just have to take the two middle numbers in the array and then do by 2 to get the median. So this is what is given, and there are three methods: median finder, which initializes the object, and then adds the integer num from the data stream to the data structure, and then find median returns the median of all the elements so far. Answer within 10 power minus 5 of the actual answer will be accepted. So now let's understand this. So we will take this example. And so initially we are going to initialize the median. This is done. Then add number. So initially we will add a number, then again we'll add a number 2, and then find median. So since it is a like even list, this is 3 by 2 is not 1.5, right? So we are going to return 1.5, and then again we'll add a number, that is 1, 2, 3, and then we are going to calculate the median. Median here is just 2, so we are going to just return median as 2. So now these are the numbers which are given in a sorted order. So let's take couple of random numbers. So let's consider these are the numbers which are coming in this stream. So first initially we'll get 6. So I'm just ensuring that whenever we add a number, we are kind of calculating the median just for our understanding purpose. But in the problem, whenever they call find median, only then we have to return. So 6, the median will be just 6. And when we get 3, so if you observe, if I put 3 here, it's still okay for the two elements, but if it has more elements, we will not be able to find the right median because it should be in the sorted format. So now it will be 9 by 2, 4.5, right? When I get 2 I have to insert in the front, not at the back. So the median here is 3. And when I get 1, again I need to insert it in the front and not anywhere else. So the median again now here is 2 plus 3 by 2, 5 by 2 is 2.5, right? And then again I get 5. I know that again I have to maintain this list in a sorted order to ensure that I kind of get the right median. Now in this case, if you observe, there are odd number of elements, so my median will be just 3. And 7, I will be inserting it towards the end. Now there are 2 elements. Now this will be 3 plus 5, 8. 8 by 2 is 4. And then I get 2 again. I have to insert it here. And now the number of elements are odd, so I just have to return the mid value, that is nothing but 3. So if you observe, so all the entire thing is, so we are getting a max element from this, let's say, sublist 1, minimum element from sublist 2. And if this particular, if one of the sublist is greater, let's say for example the number of elements in this sublist 1 is 4 and this is 3, in this case we will return just the max element from here. But if the, let's say I had, instead of this, let's say I have 5, 5, then I can just return minimum element from this particular list. right? But if it is equal 4 and 4, then we'll have to take max and min 3 plus 5 by 2. That is how we are going to get the median. So in order to simulate the same behavior, we are going to use something called as min heaps and max heap, where we are going to get the maximum element from one of the sublist and minimum elements from the other sublist. So we are going to calculate the same thing again. As mentioned already, I am going to calculate median for every insertions into the max or min heap, but in the problem statement, only when they give find median, that's when you just have to return that. So now let's say, for example, this is max heap, because we need to get maximum from this sublist, and minimum heap, and all elements should be less than or equal to all elements in the min heap. This is important. So initially I get 6, I'll insert into this particular max heap. Now we can still have difference of 1 between the two heaps, because if there are odd number of elements, they will any which ways be like needed to be like at least one number will be more in one of the heaps. That is the case. Now I get 3. Let's consider 3. Is 3 less than or equal to 6? Yes. So I'll insert it here. But if you actually see, there are 2 elements here and 0 elements in this case. So there is an imbalance, right? So what we have to do, I have to delete the maximum and insert 6. Okay. And now let's consider if I'm kind of getting median, what will I do? I'll get the max from here, min from here, that is nothing but 3 plus 6 by 2. 9 by 2 will be 4.5. Now again I'll insert 2. When I'm inserting 2, I will insert 2 because 2 is less than or equal to the max value in the max heap. Now it's still fine because the difference is just 1. As we discussed, it's okay. Now again, if I have to find the median, it is 3 plus 6 by 2, 4.5, which is already there. Now I have to insert 1. 1 is again less than or equal to the max in the max heap. So, but now the problem here is that they are imbalanced. Now when they are imbalanced, what do I need to do? I need to delete the maximum element from here and push it into the minimum heap. Now the median value here will be 2 plus 3 by 2, 5 by 2 will be 2.5. And then I will be inserting 5 now. So 5 less than or equal to the max in the max heap? No. In that case, we are going to insert 5 into the min heap. Now it's still fine because all the elements in max heap are less than or equal to all the elements in min heap, and the difference between the sizes is just 1. So we are good here. And if I have to find the median, the number of elements here are greater, so I just can return the minimum value of this. Minimum value from this heap is 3, so our median will be 3. Now I need to insert 7. So again, is 7 less than or equal to 2? No, definitely not. But so I'll be inserting into the min heap. But if you observe, the total number of elements on max heap is 2, total number of elements in min heap is 4. This is imbalance. There can be at least one element difference in between max and min. So I have to delete the minimum from here and insert it into the max heap. Right? Now again I get 2. So is 2 less than or equal to 3? Yes. So I will be inserting into the max heap. And if you see, the number of elements here are 4. The number of elements here are 3. So we are good. And all the elements 1, 2, 2, 3 are less than or equal to like 5, 6, 7. So here we are good. So now if we have to calculate the median, we will just return 3 because there are 4 elements, and if there are 4 elements we just have to return the element from, because if there are odd length then there is only one median value, right? We don't have to take the average, so this will be the answer. So now let's write the code for this. So let me max so let's say if we are getting the first element, that means the max heap dot size will be 0. In that case we are just inserting into the max heap, or if the number is less than or equal to max heap max value, front will return the max value. So in that case we are just going to insert the element into the max heap, else we are going to insert it into min heap. Now if max heap dot size is greater than min heap dot size plus 1, that means one element imbalance is fine, but otherwise we have to balance it off. So max heap size is greater, so I have to remove the element from the max heap and insert that into min heap. Else if the same thing applies for min heap as well, if min heap size is greater than max heap dot size plus 1, in this case we are going to delete an element from the min heap and then we are going to push it into the max heap. Done. This is for adding a number. Now whenever we want to get a median, if max heap dot size is greater than min heap dot size, that means the number of elements are odd and max heap has one extra element, which is the answer. So we are going to return this dot max heap dot front. Else if the min heap dot size is greater than max heap dot size, return min heap dot front, that is nothing but minimum element from. Else we are going to compute the average by getting the max from max heap and min from min heap and dividing it by 2. So one more thing you need to clearly observe is that max heap is the element which has all the smaller elements and min heap has all the larger elements. Why we are giving the name as max heap is because this heap will always return the maximum from this heap and this particular heap will always return the minimum from this heap. But if you actually look, max heap has all the elements smaller and min heap has all the elements larger than the max of the max heap. That is very important to understand. And now let's try to run this code. Let's submit it. Cool. So now let's understand the time complexity and space complexity of this solution. Time complexity is nothing but, let's consider there are q queries. For every query, when you are kind of inserting a number, what are we doing? We are inserting into one of the heaps. So inserting into one of the heaps will be log n, and once you insert, we are kind of delete, like if the sizes are mismatched, we are deleting and we are inserting a particular element. So deleting and inserting will be again log n. So log n plus log n. This is the overall time complexity of addition of a number. And if there are q queries and we are getting a find median, we are kind of getting just the front element of both the heaps, which is nothing but constant time. So like if we combine this, there are q queries and log n plus constant time. So this is for adding the number and this is for getting the median. And the space complexity here is big O of n, because we are using two heaps but we are storing all the n numbers. I hope the solution is clear. Thank you.